Alright, so hey everyone, myself Rohan, and today we are going to continue our next project which we started in the previous video, which was the MemeCoin Launchpad. And previously I explained you the working and structure of MemeCoin Launchpad. Today what we are going to do is we are going to write the smart contract of the Launchpad, and we'll be having two token smart contracts. First will be the token contract, and the next will be the factory contract. The major works will be present in the factory contract, and the token contract will be the general ERC20 token. So previously I thought that we can write the test cases and smart contracts together and in the Hardhat directly, but I think it will make it a longer video than it already is going to be. So I decided to break it down into two parts. First, we are going to simply write the smart contract. And in the next video, what we are going to do is we are going to write the test cases and we'll understand each and every things in detail. So let's start writing in the remix editor. Open up your remix editor as I have done it here and go to the token.sol. Created two files. First is factory.sol, which will contain all the workings of the the MemeCoin Launchpad, and a token which will create the instance of all the tokens which we are going to create. User can create individually also. The workings I have explained it in the previous video only. If you want to watch, you can go and watch it. And let's start with the smart contract of token. And what we are going to do here is we are going to simply go to ERC20 Open Zeppelin library, and we are going to copy this, and we are going to make changes in this according to our requirements. So we have ERC20, and we have taken it as the instance, like not instance, but we are inheriting the property of ERC20 token here. And let's simply name it token only. And what we are going to do is we are going to pass some names and values which individual user can create. I think it's not visible to you guys. I hope it's visible now. So let's write the yeah let's write the smart contract for this. First we are going to do is we are going to pass some values. For example, initial supply. Will pass the initial supply of the token, and it will be named like this. Let's name it token. Like the names and these symbol will be passed by the user directly. Okay, so let's directly pass it here only, like string memory name, string memory symbol. After that we'll be having the address of the creator, right? And sorry, after that what we are going to do is what we are going to add the total supply, uint 256. Thus initial supply only will be the total supply. Let's change it now only. Cool. So this name will be directly transferred here only, like name. The name which is passed in the token contract will be name assigned to the token which has been created, and the symbol also, right? And this creator and the other values like total supply will we can mint the total supply, and the creator will be we can write a global variable like address of owner, public owner, right? This guy is the owner of the token which has been initiated. So we'll be having owner as message dot sender, right? And since we can pay this message dot sender, we are gonna make it payable, right? Now after that, this is the owner of the complete contract which has been deployed. We have to have address of the creator also, which who has created the token. So it will be having creator, and since we are paying this owner, we have to address this payable also, right? Let's name it like the creator as creator. Cool. I think I think you guys have understood what I have written up until now. Now let's write the factory contract, which will manipulate and add or create new tokens, and all of those stuff will be done here only. So how we're gonna do that? We have to initialize it. So spdx license identifier and then pragma. Oh, sorry, it's the same thing. Sorry. Let's give it cool. After that, we have to import the this token import token, right, from this file only, token.sol. Now what we are going to do is we are going to start our contract, which is the factory contract, and in this we'll be having some variables initiated, which is first is the target public, let's name it target, right? Let's make target as 5 ethers. Cool. Now what we are going to do is we are going to, since it's also a constant actually, right? So we have to write public constant, since no one can change it. Why it is like this? Yeah. So Solidity understands when we write 5 ethers, it understands the value. That's why we can simply write 5 ethers. 5 ethers is the target till which the contract has to run. Basically, these are the one more thing. Let's add that also, uint public, and that will be also a constant, which will be the limit. Sorry, token limit. Right. Let's keep token limit of 100 ether. Right. 1,000 ether, 100 this much ether. We are going to have the token limit. It means total number of tokens that can be created. This is the limit, right? It's a huge number, so it's not an issue. So let's write the fee for individual uh, purchasing token which the investor has to pay. That will be uint 256 public and fee, right? This is the fee the investor has to pay. Now we have address of the owner who owns the contract. We'll write it down. Us only, who is going to deploy. Now we have the tokens actually. The let's write the tokens. We'll be having some tokens which will be displayed in the uh, main contract. Like for example, we have the front end. We will be having multiple tokens displayed, right? That will be an array of tokens because we have to basically iterate over those arrays. That's why we are using array instead of map. It is generally suggested to use map instead of arrays as much as possible. So, but if we need it, we cannot do anything. So, tokens, and we'll be having total number of tokens also, like the amount of token. You can directly use it by getting the length of it, so it's not much required. Or let's write it down. You went 256 256 public total tokens, right? I mean, it's not needed to be honest, but let's remove it. We can directly use the length of the address which we have. After that, we have mapping of, what do we say? Mm, all right, let's create a struct also for individual tokens. Will be having, like, the token will have individual tokens will be having some values, right? So let's write that also. What we are going to do is we are going to create a struct of token sale, right? And we'll be having address of token, string will be having a token name, token address, token name, total sold, event 256, sold tokens. After that, the creator also, address will be creator, right? uh, for, I don't think there's anything else. Oh, whether the token is open or not, that will be boolean, is open. Cool. After that, we have target also. So, and the token limit, we have to add the raised amount also. So we will be writing total amount raised also 256, raised total amount which has been raised by the particular token which has been called. This is a struct, and using this struct we are going to create a mapping which will be mapping of an address, individual address of the token, and we'll be using this token sale, and it will be called token to sale. Cool. um, I think it's yeah, these are the things that we need, I think. Let's add some events also, right? Because we are going to need events also when the user created the token, when the user withdrawed the token, all of those stuff, right? So let's call an event of created, and we are going to pass the address. It will be indexed of token, sorry, token, and event, someone buys the token, this event will be triggered, indexed token, and the amount. So event 256 amount. When the user creates any token, this event will be triggered. When the user buys any token, the investor, basically, this event will be triggered. So now let's write the constructor, right? Will be when we create this or deploy the smart contract, what things are we going to pass? We're going to get the owner and the fee, because these things are constant. So fee we should pass, which is event, right? Event 256, fees. So fee will be fee, and the owner will be message dot sender, us, the deployer, the person who deployed, right? Now let's write the very first smart contracts function, which will be create. Someone creates the the token. If someone comes into our platform and he wants to create the token, let's write that function. So function, let's name it create, right? And we will be having the name, memory name, and what else was that? We have name and symbol. All right, string memory symbol. Cool. And other things like name, symbol, creator, we can directly get. Total supply is can be changed and manipulated in the struct. We have sold, right? So we are going to manipulate through that only. All right, so it is a payable function and it is external also. So first, what we're going to do is we have to have a minimum criteria, right, which we have set it for fees. Like at least the user should pass at least this much amount of fees. So let's use a require function, I mean the constraint, that the message dot value should be greater than or at least equal to the fee which has been given. Else this message will be said that um, fee uh, transferred value is less than the fees required. Make sense? All right. Now, if the user is passing more value than the fees which we have already declared, we'll move forward and we'll create a token. So we'll take the like the this value token. We're going to initialize it. A new, sorry for the background. I'm really sorry. New token. New token, and in this we are going to pass some values which will be mm, sorry, this new token will have some values, right? So all right, total supply, name, symbol, creator, that's it. Okay, so let's write the total supply. We will be having supply, total supply or something like that, was there, right? Total supply. Okay, let's directly create, no, not directly create, total supply. Okay, sorry, we have to pass it directly. Message dot sender will be the person who created it, right? Let's do it like this. Creator first, right? So we can message dot sender. After that we'll be having total supply of let's get give again this that much only, ether, right? The name will be the name which was passed here, yeah, this one, name, right? And after that I hope it is symbol, yeah, symbol. Okay, so symbol. So we have to maintain the structure which we have passed here only. Address is the first, so we first pass the message dot sender, total supply, name, and the symbol. That's how the new token gets created. Cool. Now, if the new token gets created, what we are going to do is we are going to push the new token into the array of tokens, because new token has been created. uh, Tokens dot push, just a minute, we have address, array of addresses, right? So new token, and yeah, okay, address of new token. Makes sense. How the total tokens length will be increased, this all right. What next we can do is, we have already created the token. So but this token to sale, we have to transfer the values to token to sale also. Actually, we have to create a instance of the struct also now, not the instant instance but the value. So token to token sale, um inside a function we are. So just try it out once. Sorry, token sale with values of address will be token address, address of token. I think it's expected identity. I think I'm not following certain ways that it should be done. um mm, mm, mm. Okay, we have to pass memory, and now we have to pass 6 arguments, right? First we'll be having name. All right, so let's pass first the address, right? Is it address? This token, sorry, token. Token will be address of the token, new token basically. Address of a new token. After that, yeah, we are in the right path. We'll pass the name as the name which was given here only. After that, oh sorry, after that we have sold, which is uint. So sold will be the amount which has been sold. So currently we have 0 amounts sold, right? Because it is already created. After that, we have creator. Creator is the message.sender who has called this function, right? And then we have is open, which is currently it's open, so true. And after that we have raised will be 0, because initially we haven't raised any value. This sale struct format variable which we have created, it should be added to this token to sale. So how we going to add token to sale with the address of this um, new token, address of new token, sorry, token, yeah, will be passed to this one, sale value will be passed to, oh sorry, in the brackets. So the sale value which we have created right now will be passed to the token to sale. Now token to sale contains one of the tokens which has been created, and that is open for sale. Now let's if we have created sale token, we can write down the, I mean, since it is, yeah, all right, so emit the created event also, created, right? And what are the values? Address of the token, so address of new token. Cool, makes sense. Um, create, if someone creates then it's all good. After that, we have to write, um, there's something wrong here. Created, expected. Oh, sorry. Emit. Yeah. If someone can create, someone can buy. So let's write the function for buy. Buy. And in order to buy, we have to pass the address of the token which we have to buy, token, and the total amount of the token that we have to buy, amount, right? And it is payable, and it will be an external function. Cool. So what we have to do is we have to create again the token, the struct value. First we have to, because the token which we have to buy, we have to check first if it is present or not, right? And by default, mapping does not say that we don't have that value. It's not like that. We cannot iterate also. So let's first create the struct token sale, um, from storage, because we are doing it inside the function sale token to sale. This array token to sale, sorry, in this map will pass the address of the token, right? Now we have to check certain requirements. First, this uh, array, this token which we have called from the map, we have to check whether this token is available for sale or not. How we are going to check? We have to check whether it is open or not, open for sale. That's why it is, we have passed open. So let's pass the require function, and we'll check sale dot is open, um, equals true. If yes, then we'll move forward. Else, token is not currently for sale. Cool. Make sense? If token is for sale, then we'll move forward. Else, we're not going to move forward. Next, we are going to check the amount. Yeah, let's check the amount which has been passed is greater than the required amount, right? So amount should be greater than, at least equal to 1 ether, the required amount passed. Else we'll call out that factory not, I mean, amount transferred is too low. Make sense? Now we have to also check whether the amount which we have passed should not exceed the required amount. Like, we have to put on some barrier also, because if the single person purchase every token, or if the single person pays a lot of money just to buy the token, and the whole token goes to him, it will be difficult for further other peoples also to take the token. So what we're going to do is we have to, like, put on an upper limit also. So amount should be less than 1,000 ether, right? No one is going to pass pay 1,000 ether, but okay. Amount is too high. All right. Now what we are going to do is we are going to calculate the cost. For that, I have to show you something. I think it's visible. Let's go to chat GPT. I was searching one thing today, and I found out that this method of, there's one method. I'll show you, just a minute. Yeah, okay. So this method I was also learning from a YouTube video. I learned that this format, this way of calculating the cost, is there's a proper uh, function to calculate the cost of every token based on the amount of token that has been transferred, which is, let's see, the cost calculates the price. The get cost function, which we'll be creating right now, is the in the contract calculates the price of one token based on how many tokens have already sold. So the price of the token depends on the amount of the token which has been sold. The price increases as more tokens are sold, and it is called the step based pricing system, or sliding scale, or tiered pricing, sorry. So how it works, we have two values. First is the floor, no, three values. First is the floor, the minimum amount which the token has in initially when none of the token has been bought. And the step is the increment values through which the token price will be incremented. And the increment is the amount of uh, monies that will be transferred on based on how much values that needs to be incremented. I know it's confusing, but let's go through the step by step to understand it better. So the base price, which is floor, is the token. Every token starts with the minimum price of 0.0001 ETH, right? This is the minimum price of token. Step is the step at which every 10,000 token, for example, we have taken 10,000 increment. So the increment price will be the step, and step is for every 10,000 tokens sold, 10,000, the price increases by 0.0001 ETH. This step, right? I hope I'm clear. Increment is the amount, and this step is the step that gets incremented. Base price is the minimum value. Increment price is the uh, for every 10,000 sold tokens, the price will increase by this value. 10,000 tokens sold, 0.0001 ETH value incremented. That's how. We'll understand through an example. The price of token depends on how many tokens have been sold so far. True. For example, we have zero uh, tokens in the range of 0 to 9,999. The price is just the floor price, right? And as soon as the price the tokens sold the number of tokens sold gets 10,000, the price incremented by one step, that is 0.001, gets added to this, that becomes 0.0002 for every 20,000, and this value will be consistent till the total number of tokens sold gets to the point of 19,999. As the total number of tokens sold gets to 20,000, the price becomes again incremented by 0.0001, the step. And this is the formula for it, right? If you add into it, for example, sold tokens is, uh, let's suppose we say sold token is 9,999, and the increment is this 10,000. So 9,999 by 10,000. It is almost zero, right? Because calculate it in the sense of non-zero. Like we are not going to this decimal part of it. And after that, what we are going to do is we are going to multiply the step into it. So 0 into step equals 0 only. And after that, we are going to add the floor. So for the value of this 9,999, we added 9,999 divided by 10,000, which is 0, and it multiplied anything with 0 equals 0 only, plus floor value, which is 0.0001. So till 9,000 also, for 9,000 also, the price was 0.0001. For 10,000, what happened was we added the value of sold as 10,000 divided by increment, which is also 10,000. So both got cancelled. The remainder was 1 here. 1 into step. What is step? 0.001. The 1 into 0.0001 becomes 0.0001, and that 0.0001 gets added to the floor value, which was 0.0001. So 0001 plus 0.0001 equals 0.0002. One step got incremented as soon as it gets here. Similarly, for this also, you'll get that value only, because 20,000 divided by 10,000 will get 2. 2 into 0.0001 will be 0.0002, and plus 0.0001 equals 0.0003. Yeah, that is the step. I think I am clear with what I wanted to explain. It's a bit confusing, but if you understand the process, you'll understand it. So let's write the sold tokens. We have to write the first. Let's write the buy. Yeah, if we have written the bot, no, we haven't written. We have to write this function also. Actually, let's write it down. All right. So for we'll write get cost, means getting cost of each number of tokens. Mhm. We have to pass total number of tokens, sorry, total number of fee which we have transferred, right? Sorry, not uh, it's not fee, it's token only, sorry, sold tokens only. And it will be public and returns a uint value, right? Total cost, it's a uint value, and it's pure also because it's not changing anything. Sorry, pure. Okay, now we will introduce these values which we have discussed. um, uint 256, sorry, uint 256 floor equals 0.000001 ether, and step will be also equal to 0.000001 ether, and the increment will be a 10,000. 10,000, 10,000, yeah, ether. Now let's use these values. We have to calculate the cost based on these values. Uint 256 cost is, we have to first calculate the current sold tokens divided by the increment, right? So as to get this value, sold tokens divided by increment, right? We got it. And after that, we will multiply it with step, right? The step for every step increment, and then we'll add floor into it, tokens. Let's return this cost. And you might question where we are going to use it. We are going to use it in the buy only, because we got the cost of total token, like current tokens, based on the total tokens which was purchased by the investors. So let's write the buy for, we'll get the cost of the tokens which will get cost, and we'll transfer the sold tokens total amount. Yep. But here we are going to pass something else. You might question what it is. We are going to get it through this sale dot sold. Yeah, That's it. Total tokens sold from this token will be passed here only. All right. Now we'll be having price of the token, which will be the cost of individual token into the amount which we have transferred, divided by 10 to the power 18. That's how, yeah, ethers, we are converting it into ethers, sorry, ways from ethers. That's why we are calculating it through this. This is the way to convert to wave format from ethers. That's why. Now if we have converted it, we'll check the message dot value transferred again. Oh, we haven't checked it here. I don't think we have to check it. Okay, is greater than the price which the message dot value passed is greater than the price which we calculated, then all good. Otherwise we'll say that the ETH transferred was um, less or insufficient. ETH transferred was insufficient. I hope it makes sense. Now let's understand. We will update these values also now, since we have sold more tokens, and the total amount raised also incremented. Previously it was zero only, sold and raised. Let's write it together only. It, yeah, okay. Sold and raised tokens now both will be getting incremented. Let's write it. Sale, this sale dot sold will be incremented by the amount which was passed, and the total raised tokens, sorry, dot raised will also be incremented by the price which was calculated, the final price based on the cost of individual tokens. Cool. Now we have to, I think buy is ready. Now we have to add a constraint also. Like if we have to check after purchasing everything, we have to check whether the total tokens sold and total amount raised, does it uh, reaching out the end line, like the total amount of tokens which we wanted users to purchase, is it the getting it to the end? For example, the token limit which we had, we have to check the limit for both. We have to check whether the target is achieved and the token limit has been achieved. If yes, we will change this is open to is closed, because now this token has been, its tokens limit has been achieved. Now we don't have to sell it. So let's add the constraint here only. Yeah, if sale dot the sold value after addition is greater than or at least equal to the token limit, limit, okay, yeah, or sold dot raised, total raised is greater than the target which we had. Target is for every token. If that's the sale, then if that's the case, then we'll say that sale dot is open to false. Now we are not selling this token which was previously opened. Now this is, and same cheese we are checking it here also. No, not here. Well, in the buy only, right? I think, yeah, is open. So if now this same token someone wants to purchase and he calls out this function, what will happen is the first line will only reject it, because now the is open has been changed if it exceeds the token limit or the target. That's the main thing. um, I think everything is done. Emit. Oh, so let's add the emit for buy also. I think I have written the buy emit. Yeah, here only, no? Yeah. Okay. Token. What is the token name? Huh? I think I got confused. Um, Token only. Oh, sorry. And the amount which was transferred. That's the sold. Wait. Amount. Yeah. What's wrong with that? Oh, we're not emitting it. Sorry. Okay. So this was for buy also. Wait. There's one more thing actually. We have to, if someone calls out this buy and purchases the token, in return the values which he has transferred in the message dot value which we were calculating previously, we have to transfer it to the this, what do we say, message dot sender, right? Sorry, not the message dot value but the amount which he has purchased. We're not sending it to him, so let's transfer it. Token, this token dot transfer. It's not giving me transfer. Okay, let's move without it. Message dot sender, the one who called it, will pass him the amount, and then we'll say that by function is working now. Okay, so we have three functions ready, and now we have to write the deposit function. There are two functions left actually. um let's write it down fast and quickly. First is the deposit, uh, deposit function, which will be um, sorry, deposit. And if someone wants to deposit, not someone specifically, we have to check. Actually, deposit, we can add one thing. Okay, let's move for someone calls out the deposit token and it's external, right? Anyone can use it, let it be. Anyone can call out. We just have to check whether the is open is currently available or not. Like if it is false, we cannot, because the target, the limit which has been given to the function has not reached. So deposit will create the instance first. N- New, not new token, token equals uh, token with the address of this, right? Now let's call out the struct token sale, right? And we are in the function, so use memory sale, right? And we'll call token to sale with that address, right? So we called out the token from the struct to get all the details. It has that is open, token name, sold, creator, everything. Just to get those details, we called out this, right? Now we are going to check this require sale is open. If it is false, it means that token has been reached, like it has reached his limit, its limit. That's why it is closed or it is false. So we are not, we can deposit this token now. The whole purpose of depositing the token is to deposit those tokens whose limit has been reached, or they have raised the total target which was required. Those tokens will be deposited. So in order to check if those tokens are have reached their limits, we'll check through it whether it is open or not, because if they have, it will already get set to false. And if they haven't reached their limit, we'll say that token has not reached their limit. That's it. If it is false, it means it has reached the limit and we can deposit it and we can move forward. So what we are going to do, we can transfer it now. Transfer sale dot creator. So I'll write it down and explain it to you. And what we are going to transfer, token dot balance of the message dot this, address dot this, right? The smart contract. So what we are going to do is we will check first whether the token has reached its limit or not. If yes, then we'll move forward. If no, we'll set that token has not reached the limit or the target which was defined. So when moving forward, what we'll do is if it has reached the limit, we'll call out the creator of this token, the one who created this token, who called this create function. While creating this, the person who called this create function, right, will be given here only, and will transfer all the balance of the smart contract to that creator, because this, it has reached its limit, like the target which it had, it has reached it. So the tokens which is present currently will be transferred directly. You can either instead do something else also with those tokens, the left out tokens. But what I'm doing is the balance which are present in the smart contract, we can directly transfer it to the person who created it. So the it will be transferred, and the money which was raised, so as while like creating these tokens, will pay all the money to the creator only. That's our small scale goal kind of thing. It reached its limit, so all the money now, let's transfer it to the creator only. And we'll call the, sorry, value will be sale dot raised. All the raised value which we raised will be transferred to the creator. And okay, and if it is success, let's do it, sorry, success and good, but else payment to the creator wasn't successful. Cool, makes sense. This was deposit, and now let's withdraw the tokens. The creator can only the withdraw the tokens. So let's write withdraw, right? You went 256 amount, right? And okay, it's public, but only with user can withdraw. Require, will add the constraint message dot sender should be equals to owner. If not, we'll call out unauthorized, you are not the owner. Cool. If you are the owner, we'll all withdraw all the tokens, and we'll write down the same thing actually. Wait. Mm-hmm. This is. Let me write down myself only. Require was done. Then let's write down bool success, right? And payable, and we're going to pay the owner. And what we'll call the value, and what we are going to pay the amount which was called by the owner, right? And after that, if it is success, payment to the owner wasn't successful. So this was the Solidity code for our MemeCoin Launchpad. Please make a note of something. This is not a decentralized exchange we are building. We are building a launchpad. It means the token which gets launched, like if it raised a particular amount of like the maximum limit which was considered for it to gain, that token will be transferred to the decentralized exchange for further exchanges and all, and the investor will get the uh, profit accordingly, and the developer also. This is not the decentralized exchange, this is the launch pad. That's why the code is a bit different than the dex. You can check it out, and after writing this code I'll make sure to uh, add the GitHub repo in the final part of the video which will create. It will be mostly 3 to 4 part video. It is the second part, will have 2 3 parts more, and by the end I will cover it up. And we are going to use Hardhat for the process, like testing also. Like for the thing which we are going to do is test, so we are going to use Hardhat with the testing framework as Mocha with Chai, and we'll deploy it on Hardhat also. As one of my viewers was asking to use Hardhat just to deploy it because he's facing some issues. I wanted to create this product for a very long time because he told me. So let's do it now today only. In the next video, we are going to use Hardhat. And till now, this was it for today. And I hope you guys enjoyed the video and found it informative. And if you do, make sure to like and subscribe and follow for more. Thank you.